Hi, in this particular session, let us look at some basics of circles. First, let us look at what a circle is. So, everybody must have seen a circle. So, what's this? It's something like this. So, each circle has a center, a point, from which every point on the circle is at a fixed distance. So, if I were to take the distance at any of these places, so this is A0, O, and this would be A1, A2, A3, A4, A5. Each of these points is at a distance of R or a particular radius. So OA1, OA2, OA3, OA4, they all are at the same distance from the center. So this distance is known as the radius. Now, if I have a circle and if I draw a line, so this is the center, and if I draw a line through the center, the total distance would be 2r. This is twice the radius because from this point O to here A and from O to B, both of these would be radius and the total distance is 2r. This is also called the diameter of the circle. Now, now we have looked at radius and we have looked at diameter. Now, let us look at another term. If we draw a circle and from one point to one of the other points in the circle, I draw a straight line from one point to another. The center is somewhere here. So AB, this straight line connecting any 2 points in a circle, in the same circle, is called a chord. CHORD. So AB is a chord. So the longest chord would be the diameter. The longest chord would be the diameter, that is, which is passing through the center. That would be the longest chord. And now, what is arc? Let us say, let me take 2 points A, B. This distance here, or this line here joining this A and B like this, that is part of the circle, that is called arc. Now there are two arcs. To join these 2 points, I could go all the way this side and come back. Okay, so let me take this as A dash B dash because we already have A and B over here. So I could go all the way round and then come back to B, or I could take the short route. This short route is called the minor arc. Minor arc. The long one is called major arc. So A dash minor arc A dash B dash would mean this one, this particular one, and the major arc A dash B dash would mean from here to here. Now let us look at some more terms. What is the circumference of a circle? It is nothing but the total length or the perimeter of a circle. So suppose I start from this point A and I walk all around the circle and come back to the same point, the total distance that I cover, that would be the circumference. So basically it is the length of the complete circle. So if I were to cut open this circle and lay it straight like a straight line, the total length, that would be the circumference. Now what is a semicircle? Semicircle is only half the circle, half of this circle. This is the, what you call it as, semicircle. So half the circle is semicircle. Now let's look at the next term. The next term that I want to talk about is congruent circles. What are congruent circles? If I have one circle and another circle, and if I were to take these two circles and place them one on top of the other, it will exactly coincide. That means the radius of this would be equal to the radius of the second one. Then they would be called congruent. So these are congruent circles. Now, if I have a circle here and I draw a line from A to B over here. Now this is the chord AB, and this part here, this would be called minor segment, which has the smaller area. This part here, which has more area, this is called major segment. Now let us see two other terms. So I have O over here, the center, and I have A and I have a B. This is arc AB, minor arc AB, and if I were to go from here to here, it would be major arc AB. So let me connect A and this and this. So this area here, this is called a sector. Sector OAB or AOB. And since this area is smaller than the part left out, this would be called minor sector. And if I were to mention major sector, it would all be the rest of the thing. So if I say major sector AOB, it is this part, which is the major sector. Now let's talk about one more important thing. It is called cyclic quadrilateral. Suppose, what is a cyclic quadrilateral? I have a circle, and in this circle, let me take any 4 points. So here to here, and then here, and then here, and then back there. Okay. Sorry, it's creating a little problem for me over here. Let me redraw it. It should be let's draw a circle first, and then okay. So I have this as A, B, C, and D. So what is this? This is called this is a quadrilateral that I have drawn inside a circle, touching all the vertices of the quadrilateral are touching the circle. So ABCD is a quadrilateral. Now the this kind of quadrilateral where every point touches a circle, this is called a cyclic quadrilateral. Now, what is the interesting property of a cyclic quadrilateral? If I were to take opposite angles, the sum of the opposite angles, that is angle B plus angle D, this would be 180 degree. That is, the sum of the opposite angles are supplementary. Similarly, angle A plus angle C would be 180 degree. So this is what we mean by a cyclic quadrilateral. If a quadrilateral is there where the opposite angles are supplementary, then it means that I could draw a circle such that all the 4 points touch the circle. Then another term that I would like to introduce is common chord. Common chord. Suppose I have a circle here and I have another circle. Now, if I were to draw a line from this point O to O dash, this O dash is a chord in circle A as well as being a chord in circle B. So it is created out of joining the points of intersection of these two circles. So this is known as a common chord. Thank you. The next session we would be looking at some more important theorems.